Today, we have a pretty short lesson. It's going to be talking about standard solutions. But because we are coming out of spring break, this is a good time for us to do some review. So just as usual, you take a moment, do the review problems, and then when you're ready, you can unpause. Right, so we are going to be looking for the concentration of magnesium hydroxide. So what we've done is we've taken a mass, we've weighed it out, we want to dissolve it into 670 milliliters of water, and we want to determine what concentration we'll actually have in that solution. So we are looking for the concentration of magnesium hydroxide. To do that, we have to start with what we know. We know that there is 3.5 grams. Now, you'll probably ask me, which one do I choose, the volume or the grams? I will always choose the mass first when I have mass because I can convert that into moles, okay? And moles is, again, the goal units for concentration. So the goal units we are looking for is moles per liter. So I want to get this problematic thing dealt with first. So 3.5 grams times by. Now to turn this into moles, we need to use a converter. And to go from grams to moles, we will be using molar mass. The molar mass of this compound is 58.33 grams per mole. Remember, any sort of converter has 2 units, and you can use that to complete unit analysis. So I'm going to throw moles on top and 58.33 grams in the denominator, okay? Grams cancels out with grams, and I have moles. Now, to get me to my goal units, I need moles in the numerator and volume in the denominator. Okay, because volume is actually part of our goal units, I want to use it at the end. That's why I go with grams first. Okay, so I'm going to divide by 0.670 liters. Remember, liters, and they've given us milliliters here. So to get that number, I divide by 1,000, which is the same thing as moving your decimal point 3 places over. Perfect. So once we plug that in, get rid of that equal sign. Once we plug that in, we get a concentration to 3 significant digits of 0.0896 moles per liter. Or we can represent it as 0.0896 capital M. Remember that capital M is the same as moles per liter. Perfect. So let's go. Okay, so here we are now asked to determine the ion concentrations. So once we've dissolved magnesium hydroxide into that solution, what are the actual concentrations of these ions? Okay, so the first thing you need to do is write a balanced reaction. Here, I'll write the steps out for you guys. So, first step. Is a balanced reaction. So we take magnesium hydroxide, and I know a lot of you will be like, this compound's not really soluble in water. I know, but we're going to use it for the purpose of this example. So this is going to split into the 2 ions, magnesium 2 plus, aqueous, and then plus 2 hydroxide ions, aqueous. Perfect. So from here, let's list our known and our unknown. Remember, you have to write a molar ratio statement for each known and for each unknown. So I'm going to do actually hydroxide first. So we know we have 0.0896 mole per liter of this compound. And then I'm going to look for this one first. So we're looking for that, and it needs to be concentration. Okay, so that's step 2. Step 2 is list your known and your unknown. Step 3 is use your molar ratio. So you begin with what you know, 0.0896 mole per liter of magnesium hydroxide. Perfect, so we need to now convert this. So remember, when you are going from a known to an unknown entity in a chemical reaction, you will use a molar ratio. Okay, and this is where balancing your reaction comes in handy. If you balance this reaction incorrectly, your molar ratio is going to be incorrect as well. So we need to get rid of magnesium hydroxide down here. And to do that, I need to find the molar ratio of magnesium hydroxide, which is 1. Remember, 1s are invisible in chemistry. So 1 mole of magnesium hydroxide. This allows us to cancel out magnesium hydroxide. Now, we are looking for this guy. So we need to multiply by 2 moles of our hydroxide ion. Perfect. So this cancels out moles. Once we plug this all in, you will get an answer of 0.179 mole per liter of your hydroxide ion. There's your final answer. I want you to do magnesium on your own. When you're ready, you can unpause, and I will put the answers right there. Okay, there's your answers. You will get the same concentration for magnesium ion because it is a 1-to-1 ratio between these two. See how it has a coefficient of 1 and a coefficient of 1? Because their coefficients are the same, the concentration will remain the same. So today's lesson is we're going to determine the concentration of a standard solution. So we've already been doing this. This is taking a mass and dissociating it within a liquid and then determining its concentration. Also, we will be learning how to prepare a standard solution within a lab setting. All right, so in a laboratory setting, we make these things called standard solutions. Basically, what a standard solution is a solution with high certainty of concentration. That means the concentration, if it says it's 0.5 moles per liter, then it is exactly 0.5 meters. So solution, okay, hold on. I'm gonna write this word in the back. Okay, so it's a solution with a high concentration certainty. So we create a standard solution from a mass, from a solid mass. So basically, if we're in the lab and we want to create 100 milliliters of 0.5 mole per liter solution, we need to find out what mass we need. So we're going to calculate mass, and that's going to be the mass that we're going to dissolve so that we can have a certain concentration. Okay, so obviously when you get higher up and you do this at a higher level, you will be using scales that measure to more accuracy. In the high school level, we have a maximum of 2 decimal points on our scales. It will get us roughly close, but we won't be super certain with our precision tools, okay? So we are looking for the mass of ammonium sulfate. Okay, so mass of ammonium sulfate. Okay, so to do this, again, you're going to start with your known. Okay, that's the thing that you know, and you have 1 unit in it. So 0.100 liters. Again, you don't use milliliters when you're doing this, you use liters. We then need to convert this into moles because moles gets us to mass, okay? So we use our concentration. 0.500 mole per liter. Okay, this is where I do not want to use the capital M. I want to break it up into the actual units. So from there, I have it in my pen. Liters cancels out. Now, if we have moles, we can get mass. We have to use a specific converter. Our converter is going to be molar mass. That is a horrible line. It's going to be molar mass. Okay, so the molar mass of this compound is 137.17 grams per mole. Mole cancels out with mole, and we have units of grams. That's perfect because we're looking for mass. Once we plug that all into our calculator, we get 6.86 grams. Now, in a lab setting, these decimal points are dependent on how many decimal points that you will have on your scale. So if you have 1, then you'd probably have 6.9 grams of this. If you had 2 decimal points, then 8.6. If you had 3, the more decimal points you can have on a scale, the more accurate your concentration will be, okay? For our lab setting, let's say it's 2 decimal places. Okay, you're gonna try this one on your own. I want you to calculate the mass, round it to 3 significant digits, and then so pause, do that, and then we will come back and you can check your answer. Right, let's go through this. So we are looking for the mass of sodium sulfate. So there's the chemical formula right there. You're going to start with your known, which is your volume, okay? And it needs to be in liters. You then need to take your liters and convert it into moles, okay? So use your concentration. Then you're going to be left with moles because liters will cancel out with each other. Okay, so you have your concentration in moles per liter, count, you're left with moles. You need to convert that moles into mass. So you're going to use molar mass. So you're going to go moles and whatever your molar mass is. Okay, mole cancels out and you will get an answer of 107. Okay, so it's on you to appropriately plug these values in. Okay, so since I can't be there to do a demo for you, I'm going to link a YouTube video below, and then you will write the procedure out for preparing a standard solution. Okay.